Okay, so what is a model? Simplified representation of a part of the real world. Okay, the system of your interest. Okay, it may be a car system, it may be a public transport system, a highway system. So you choose a system and then you try to represent it in a simplified manner through some equations or through maybe a physical model. Okay, and your the model needs to focus on certain elements of the system. Okay, you cannot cover each and everything. For example, if you are talking about a model of a car, okay, then you cannot cover driver behavior if you are focusing on car, right? If you are talking about public transport, for example, so you are only focused about public transport, you may not be covering the aspects of administration. Okay, so a model is limited because of a particular point of view. What are the elements which are of interest to you from the system? So first of all, you pick the system, and from that system you pick up what you need. Okay, the elements which you need for the model. Models can be physical or abstract. Physical models or abstract model. I think physical model is very clear, right? You have a physical, something physical in front of you. Okay, so you must have, I don't know, I've heard that now it is in schools they do this exercise. They will ask the kids to make a model, a cardboard or a wooden model of an airplane or an airport or a tree or something. These are all physical models, right? These are all physical models. A map, what is a map? A map is a physical model. Okay, so you are showing the thing on something physical. Then we have abstract model, which are made mentally, analytically, or mathematically. Okay, so you have a mental map of how you have to go from one place to the other. Okay, that is abstract. You have certain equations which you have developed through your understanding of the system, that is analytical. Okay, so if I ask you, if I pour this much, for example, uh, equation of volume. Okay, volume of a circle, for example. Okay, a volume of a, not circle, volume of a sphere, for example, volume of a sphere. So we have an equation. Okay, so if I ask you what is the volume of a sphere, you will put the values in the equation and that you will give me the result. That is analytical. Okay, and then we have certain other models, mathematicals, where the equations are developed on the basis of your theoretical understanding. Okay, you have some theoretical understanding of the system. For example, if I increase the price, this will happen. If I reduce the price, this will happen. So this is a theory. Okay, so on the basis of that theory, you develop some equations that will be a mathematical model. Okay, so mental, analytical, and mathematical are called as abstract models. All three categories are abstract models because in all three of them you don't have any physical object which is representing the real world or the system. It's just a set of equations or something which is in your mind. Okay, so models provide, as we said earlier, simplified representations. Simplified representations. Okay, so we are trying to simplify the things for the purpose of our understanding. Okay, for the purpose of our understanding. Okay, so for example, when you say price of something increases, people will buy that thing less. Okay, it's a very simple relationship. Okay, if I increase for example, the car price, the sale of car will go down, and so on and so forth. Okay, this is a very simplified representation. Okay, and you can develop an equation on the basis of that, but we all know it may not be true. Okay, this relationship may not be true, some other factors may be affecting it, and so on and so forth. Okay, but in the end, whatever, maybe you have a fourth degree equation with a log what do you call a log scale in it and an exponential. You have seen complicated equations in structures and so many. You have done finite element, right? All of you have done finite element. All of you have done finite element, right? In your
Yes.
courses.
Yeah.
So
Yeah,
I,
doctor.
so I think you have seen the complicated equations, right? Okay, even those complicated equations are not the actual representation of a real world system. Even with those, all those complications, this is still a simplified representation. Okay, but even for developing any type of model, whether it is simplified or complicated from your point of view, it requires complex and large amounts of data. So if I give you, for example, data from U4 and I ask some modeling expert to develop a model, it will be very difficult for him. He will ask for more data. Okay, so you need complex, large amounts of data to develop models. Okay, but these models provide common grounds for policy decision making. For example, how many of you, raise your hands, okay, raise your hands. How many of you think that metro should be started in Bahrain as soon as possible? Raise your hands. How many of you think metro service, the metro bus service, which you may have seen in Dubai or some other countries, how many of you think metro service should be started in Dubai as soon as possible? Raise your hand. Whoever thinks it should be, raise your hand. No one. Okay, thank you, Safa. Okay, so now you see there's a difference in opinion. Okay, I just gave you an example. Okay, you can think of any other example. Increasing the bus fares, increasing tax on fuel, whatever. Okay, think of anything. Think of any decision. There may be a different point of view among different people. Okay, so someone may say yes, someone may say no. Then how would you take the decision? Okay, usually it's the person who is at the topmost hierarchy, but we need some common ground. So common ground is you have a mathematical model, or you have a model which is showing you the results of your decision. Okay, so if I increase the fuel price, this will happen. If I start the metro system, this will happen. So everybody will reach the same result through the model. Everybody will reach the same result. So it's a common ground for making policies and taking decisions. Okay, so there is no biasness of the opinion of the people. Okay, and through the model, when you are developing the model, you also learn about the system. Okay, you are collecting data, you are analyzing the data. Okay, you have things in front of you, and you must have visited people, you must have visited the site, the field. So you learn things when you are developing the model. Okay, models are not developed through wahi. It's not like you sleep at night and in the morning you will come up with a new equation. Okay, so models, when you're developing them, there's a whole process. So when you follow the process, you are learning about the system itself as well. Okay, so your learning as an expert is increasing through the development of the model. Okay, characteristics of transport problems. Okay, so the first characteristic is transport problems have become widespread and more severe over the years. Whatever problems they used to have, now they have become globalized. So they are not just for few countries. Okay, so you cannot say, okay, the fuel prices are only increasing for them, we don't have anything to do with it. Okay, and they have become more severe. For example, accidents, there used to be few accidents maybe 20 years ago, the number of accidents have increased and so on and so forth. So the transportation problems have become more severe and more widespread than they were few years ago. Yeah, economic growth, we think economic growth is a good thing, right? All of you would agree having economic growth, more income, more luxuries in life is good, right? And this has been happening throughout the world, but it has also generated more demand for transportation systems. More economic growth generates more demand for transportation systems. I think we talked about it in the last week's class as well. Yeah, so when these trends were happening, the above first 2 points were happening, I think I told you last week as well, transportation planning is a relatively new field. So there was a big, a long time when the above trends started to happen, but people were not paying attention to it. Okay, problems were becoming more severe. They were happening in many countries. Economic growth was generating demand, but many people did not pay attention to it. They were just going through the motion. Okay, if this is happening, we'll do this. They were, reactive. So they were looking at the fire and then running towards the fire extinguisher. Okay, so by the time you take the fire extinguisher, the fire has already grown out of hand. Okay, so there are countries, many countries in which last 20, 30 years have gone without any planning or without any proper planning. Okay, I will say, for example, Pakistan. Pakistan is a very if you search for Karachi, the transportation problems of Karachi, there you will find many articles, research articles, newspaper articles, videos. Okay, like if I search on YouTube, Google Scholar, whatever platform you search, okay, you will find many videos and papers and articles and whatnot. Okay, so it's a very good case study, not good for us people who live there, but it's a very good study for this point. It's a mega metropolitan city, more than its population is more than double the population of Bahrain. Okay, but the infrastructure is not good. Okay, and this is the reason. Resources are not unlimited. So we want to solve the problem. Where is the money? I already showed you in the previous slide. You need human resource as well. There are not enough people with expertise, not enough people who can design the system for you, updated systems, modern systems for you. Okay, so resources is another thing which is hindering your problem solving. Okay, characteristics of transportation demand. Okay, so we have talked about it earlier as well. Demand is derived through activities. You want to perform some activities, and because of that you are generating demand, transport demand. Your trip is not your purpose. Your purpose is to perform the activity through a trip, through the trip. Okay, whether you are talking about a person trip or a trip for the goods and materials. Okay, transporting something from one place to the other is not the purpose of transportation. The purpose is why the person needs it. Okay, and this demand is derived through the spatial distribution of activities. You have activities which are happening at different places. So in order to connect these activities, you need, then the demand is generated. Transport demand is generated. So I live at one place, I need to go to the other place. Okay, or I need food for myself, so I need to go and buy food, and so on and so forth. Okay, demand is qualitative and differentiated. Demand meaning when I choose the time for my travel, the mode for my travel, and anything related to my trip, it is based upon my own judgment. It is based upon my own judgment. I will. How many of you have been taught by Dr. Khalil? How many of you know Dr. Khalil? Raise your hand. How many of you? Raise your hand. Come on. Only 2 of you. Safa, Dr. Khalil did not teach you, Muhammad? Safa?
No,
He did not teach.
Dr. Nadal.
No, doctor, I didn't have anything with him.
Okay. So he was a colleague. He is still in Bahrain, but not in UOB. So he used to come by bus from Sakhir. He used to go to Sakhir campus. He lives near Sakhir, so he used to go to Sakhir campus and then come by bus to Isa Town campus. Okay, I have another colleague, another colleague who used to be here in our compound. I'm living near Isa Town campus, and he used to walk to Isa Town campus. Walk. Okay, all throughout the year, not just in winter. Throughout the year, he used to walk from Isa Town campus to our compound where we are living. Okay, so now who can think about that? They have their own reasons. Okay, for example, Dr. Khalil told me that I can sit in the bus and then I can do my thinking. Okay, and that guy used to say, I have time, my family is not there, I should keep myself physically active and so on. So I walk. So everybody has their own priorities. They have their own preferences. So you cannot generalize characteristics related to trips or transportation demand. You cannot say everybody who is a male or who is earning this much will use a car. Maybe they will not. Okay, so this is what we mean by qualitative. It is based upon the judgment of the traveler, and you don't know their preferences. Okay, differentiated in terms of days and times and space. Okay, so demand of commercial spaces higher, demand of residential spaces, transportation demand, okay, is lower. Demand peak hours higher, off peak hours lower. Demand in summer different, demand in winter different. Okay, so transportation demand is different according to different time zones and work zones and so on and so forth. Okay, the space, so because of this, because to cover this differentiation, what we do is we divide the complete space we have, the region for which we are doing the planning and modeling, we divide them into zones. Okay, we divide them into zones. Okay, so for example, commercial area is one zone, residential area is another zone, industrial area is another zone. Okay, or based upon number of units. So we divide the space into different zones, and then trips are calculated from one zone to the other. Okay, so space is divided into zones so that we can calculate demand for each zone. Okay, and then the zones are coded and so on. You can assume, or you can make the zones along a corridor, meaning in a linear form. For example, you say this is let's say Isa Town, and this is Sakhir or Manama or whatever, and then from here to here this is a corridor. So you say this is one zone, this is another zone, this is another zone. This is a very simplified method of zoning. Okay, one zone after the other, very simplified method of zoning. Okay, then we have complicated methods as well. For fulfilling transportation demand, we need some coordination between the zones. For example, a taxi service may be unsuccessful in an area where people have their own cars, for example, in a high income area. But the same taxi service may become very successful in another area which is for labor and which is for middle income group. Okay, so if you are, for example, you are starting your own taxi service, but you select the wrong area, your taxi service will go into loss. If you have done the same thing in another area, you would have been successful. So this is what we mean by coordination. Similarly, if you start a public transport service, a mass transit service, metro, whatever, along economic corridor, okay, a corridor where you have different commercial activities happening one after the other, it will be very successful. It will be very economically beneficial because you will have high demand on all the stops. But if you do the same thing along the boundary of the city, you will be less successful. Okay, it may go into loss. Okay, so this is a coordination which we are saying. Okay, fulfilling the demand, but as per needs, So every area may have a different type of demand. Okay, so this is again part of being qualitative and differentiated. It is dynamic. Okay, so for example, you may design a highway which has a capacity of 2000 vehicles per hour per lane. You may design a highway which has a capacity of 2000 vehicles per hour per lane. You calculate total demand of the day, and then you calculate average demand per hour. So let's say, for example, the total demand of the day is 24,000 vehicles. Okay, so how much you will get each hour? You divide by 24, right? So it will be 1000 vehicles per hour, right? So the average demand is 1000 vehicles per hour. So if you look at the average and then you look at the capacity of the road, it is more than enough. Okay, it's a capacity 2000, you require 1000, more than enough. But maybe out of this 24,000, 4000 vehicles come in the peak hour. 4000 vehicles come in the peak hour. So you designed according to average demand, but in the peak hour you will see the road capacity is below demand. Okay, so your design will be unsuccessful. Okay, so you have to cater for the dynamic nature of the demand. Okay, again going back to the concept of differentiation. So you need techniques to reduce the peak hour demand and spread it in the other hours of the day. Okay, obviously one thing is don't do anything, just design according to peak hour demand. So in the peak hour, you need 4,000 vehicles per hour. Design according to that, but in many cases it is not possible. As you can see on many highways, they are already up to their capacity and you still see traffic jams in the peak hour. Okay, they are already having bridges and without signals and 4 lanes in a direction, still you see traffic jams. So in that case, we can apply other techniques to spread the demand in other hours of the day. For example, you can apply flexible working hours. Flexible working hours, staggering working times. They are names given for the same type of concept. So for example, you may ask some schools or universities to start at 7 a.m. Others start at 8 a.m. Okay, and some offices, some government offices start at again 9 a.m. Some offices start at 10 a.m. and so on and so forth. Okay, so this is what we mean by staggering. Staggering means you distribute it. Flexible means like we have mostly in teaching. Yeah, we are flexible, right? We are flexible. So I may have a class in the morning and I may have a class in the evening as well. Okay, so whatever suits me. Okay, we used to have I think they still have the design offices, you know, structural design offices, consultants in Karachi. They still follow flexible working hours. So they will ask their engineers, I need this in 1 day or 2 days. I need this output from you. It's your job. Okay, you want to work from 9 to 5, do it. You want to work from 10 to 6, do it. You want to work from 8 to 4, do it in 8 to 4. I don't mind. In the end, fulfill your working hours. Okay, and you decide when you want to start, when you want to end. In the end, we want the results from you. Any of you, does any of your organizations have this methodology or strategy, staggering or flexible working hours? Obviously, we have it in UOB. Every teacher has his own working hours and so on. Any of your organizations following that?
No, doctor. For me, no.
No.
No. From
Okay.
8 to 6.
How many of you are working on site? Raise your hands. How many of you are working on site? Working on site means what? Construction site, right? Okay.
Yes, doctor.
How can you have fixed working hours? I have friends who, you know, who post their pictures after 18 hours of concreting. It doesn't happen on your sites?
In summer, it's happened, doctor.
Side.
Sorry?
Contractor side, it happened.
Yeah, and no, yes, this is what I said. You know, even if you are a consultant, if the work is happening on construction site, then you have to work according to that, right?
It happened
Yeah,
sometime
but
in
usually
summer,
contractor
doctor.
will sit all the time.
Yeah, okay. So, you know, civil engineers are doomed. Okay. A premium pricing is another technique. So if you want to go into the main area in the peak hour, so you have to pay an extra tax. Okay, so they have applied in London and Singapore, and we'll talk about it at the end of these slides today as well, inshallah. So premium pricing is paying an extra tax for entering a congested area in the peak hour. Okay, so by this, doing all these things, we intend to reduce the demand in the peak hours. Okay, so these 24,000 vehicles, okay, so that majority of them don't come in the peak hour, they are distributed. Okay, this is our. Then characteristics of transportation supply. Transportation supply is a service, not a good. It's not something physical. Okay, it's a service. For example, capacity of the highway is transport supply. Okay, so it's not a good. It's not something I can put in my pocket and walk away and, you know, take it to my home. Okay, it's not something which the government can say, okay, we need only 2 lanes in the morning, so we'll put 2 lanes on the ground, and the third lane we will put it somewhere else. It cannot happen, right? So it's a service. Okay, same thing with the seats in the bus. Okay, the bus has 40 seats. Even if them 20 of them are occupied, you still have to drive the whole bus, right? Okay, you cannot stock 20 seats for later. Okay, so transportation supply is a good, not sorry, it's a service, not a good. You cannot stock it for later. So if you need it later, you have to keep it. Okay, you have to keep it in service from start to end. Transportation systems are comprised of two main things: vehicles and infrastructure. I think we know what does it mean. Vehicles provided by different entities, and infrastructure is provided by different organizations. Okay, vehicles are provided by vehicle manufacturers. Bus transport may be handled by someone else. Truck transport may be handled by someone else. So there are multiple organizations and people who are involved in providing vehicles and infrastructure services. Okay, so this provision generates complex interactions. Okay, so the government makes a policy which is affecting the contractor and the consultant, the material provider, and so on and so forth. Okay, I think you guys may have more examples, and you guys may have more knowledge about that. Okay, how one decision which is taken at the government level can affect so many other areas and so many other organizations. Okay, it also produces economic complexities. Okay, so for example, the government wants to increase their income, so they are putting more taxes. Okay, but those taxes may be reducing the demand for example, trucks. Okay, people because of those taxes may start using less trucks or something like that. So this is the economic complexity. Okay, you are increasing the revenue from one end, but the revenue from the other end is now decreasing. There are less people who are using your service and so on. Okay, so you have to keep in mind when you are designing the transportation supply system how decision of one organization can affect the others. Transportation projects are lumpy meaning you have to provide it totally at one in one go. Okay, so for example, you cannot construct half a railway station, right? You cannot construct half an airport. You have to construct the airport fully. Okay, like I gave you the example, if you are buying one bus, it's one bus, you cannot buy half a bus. Okay, or you cannot operate half a bus. Okay, similarly, you need one highway which has 2 lanes. Okay, fine, you have to build the highway fully. Okay, but you can gradually update it. This is what they mean by culminated. So for example, I need 2 lanes in future. I may build 1 lane on each side now and 2 lanes in the future, but those 1 lanes should be developed fully. Okay, that 1 lane should have everything which is required for the movement of vehicles. Okay, you cannot say, okay, fine, the demand is low now, so I will make this lane with grass instead of asphalt. No, this will not work. Okay, so lumpy means you have to provide the complete set of service in one project. Okay, so 1 lane with all its accessories must be provided under one project. Later on you can update it, but you cannot say, okay, 1 lane without marking, 1 lane without any signal. This will not work. Okay, whatever is required for safe movement of traffic, even for the just for the peak hour, you have to keep it there for the whole day, for the complete time of the project. Transportation projects are time consuming. I think in the first lecture, some of you gave me example of bridge projects. And at that time, we discussed that some of those projects have taken 6 months, 8 months, 1 year. Okay, so they are time consuming. So they are lumpy. You have to provide everything in one project, but the projects are taking so much amount of time. Okay, so you have to keep the investment at hand, and investments can be politically influenced. People, a minister, okay, may decide, or the head of the department may decide based upon his own judgment that we should invest in this sector, or we should invest in this sector. Okay, or sometimes it is the external pressure. Somebody from the outside says that you are giving too much subsidy to your people, so you should, there are organizations, economic organizations, which do that. They will evaluate your expenditures and so on, and they will say, you are taking less taxes, or you are providing too much pension or healthcare support to your citizens. You should reduce it, increase it, whatever. So investments can be politically influenced on the basis of judgment of one individual or on the basis of external pressures. Okay, so because of that, you decide, okay, I will increase the tax on fuel, I will make a metro service, I will, I will not allow this particular type of product in my country, and so on and so forth. So investments can be politically influenced. So in that scenario, when somebody is just saying from his own judgment or from his own perspective, you will do this, we will not do that, then planning analysis becomes more important. Okay, because the person who is making the investment is not thinking from the technical point of view. So as a transportation engineer, then the planning analysis rests upon you. Okay, because the person who is providing the money is not thinking about these things. Road pricing, this is why we do road pricing. Okay, so that we can keep the investment, and we can cover the costs, and we can restrict the use of the facility. Okay, so road pricing is mainly to restrict the use of the facility so that we have efficient utilization of resources. Okay, so that's why we do road pricing. Like I said, premium pricing, road pricing, there are different names for the same concept. Basically, you are asking people to pay you extra taxes in order to use congested areas and peak hours. Okay, so if you don't do that, what will happen? People do not imagine the amount of delay they are causing because of using the facility at the same time, or using the same facility. Everybody is using or going towards the same place. They do not comprehend that we are adding to the congestion and accident. Okay, who is making the road congested? All of us, right? All of us. We are part of that system. We are part of that traffic system. So in order to realize, or the correct word is in order to internalize the cost which the traveler is causing to the other users, the accidents, the congestion, the delay, the pollution. Okay, then we do road pricing. Okay, so since the user is paying direct money, an extra amount of money directly from his pocket, so although even if he does not know anything about pollution, or he does not care about pollution and congestion and delay, even then he will be thinking about his money, and he may opt to change his trip pattern. He may go to another area, he may select another hour, he may buy online, and so on and so forth. Okay, so this is why road pricing is done, so that the marginal cost, the increase in cost because of accidents and congestion which you are causing to the system, you have to pay it from your pocket, so you realize it. Okay, so what is so we are talking about congestion. So congestion is when demand goes above capacity. Congestion is when demand goes above capacity. So you can see this curve here. Okay, and we will discuss this curve later on as well with some numerical examples. So this is the unit of travel time, 1 unit of travel time, and this is the flow of vehicles. Okay, so you can see up to a certain point the curve is straight. Okay, this is uncongested area. Up to this point is uncongested. Okay, so your when one extra vehicle is coming into the flow, it is not causing a significant increase in the travel time or significant increase in the delay. Okay, but this region, when you are close to the capacity, each vehicle which is added to the flow significantly increases the travel time for everybody. Okay, this is travel time, average travel time for all the users. Okay, so this is the area of congestion basically. So you can see how rapidly the time is increasing when I add 1 unit in the 1 unit in the traffic flow, 1 vehicle. Okay, so when I add 1 vehicle here, the travel time increases very slightly. But in this region, when I add 1 vehicle, okay, so the travel time increases more rapidly, okay, more significantly. Okay, so this is a congested region. So as a traveler, as a road user, can you estimate how much travel time I'm causing extra to the other road users? No, you cannot. Okay, so that's why we do road pricing. Okay, because you cannot imagine, you cannot comprehend as a road user that how much you are adding to the congestion of the road. So we ask you to give you some money, so you may decide to not add to that travel time if you have the choice. Okay, equilibrium, again something we'll discuss in detail later on with numerical examples as well. It is the role of transportation planning to ensure that we satisfy the demand. Like I said, demand is I have to fulfill my activities. A person needs to fulfill his activities, food, work, education. Okay, so whatever trips are generated, you cannot tell people, okay, today you will not go to buy any food. No, they have to buy food. You can provide them alternatives, alternative times and so on. Okay, so satisfy the demand. What is the equilibrium? Satisfy the demand in different times of the day using different modes in a given transportation system operating at a specific capacity. So Q is the capacity and D is the demand. Q is the capacity, D is the demand. Okay, so Q and D must meet each other. Q and D must meet each other. You should satisfy the demand using the full capacity of your system. Now keep in mind, they are not saying highway system, they are saying transport system. Okay, so total demand, some of it will be fulfilled through maybe airplanes, some of it will be fulfilled through highways, some of it will be fulfilled through trains and so on. Okay, so you have to design your system in such a way that the complete demand is fulfilled using the full capacity of the transportation system, including everything. Okay, so what influences the capacity? What influences the capacity? It's infrastructure, number of lanes, number of buses, stations, so on. Management system, okay, signals, terminals, okay, rules and regulations you have, people who are managing the system, set of modes and operators, okay, different transportation modes, rail, bus, car, taxis, and their operators. So the capacity is influenced through these things. Okay, so for example, now we will be using this form again and again, so just keep one thing in mind. This form of an equation means, how do I read this? S is a function of Q, V, and M. Okay, S is a function of Q, V, and M, meaning Q, V, and M can change S. Okay, so S can mean anything and Q, V, and M can mean anything, but I'm explaining the general form of the equation. So whenever you see this form of the equation, it means mathematically we say S is a function of Q, V, and M. And in layman terms, you can say S can change because of a change in Q, V, and M. Okay, now what is S? S is the speed by which you are making the trip. Speed by which you are making the trip, and it represents LOS. Now LOS means level of service. LOS means level of service. Okay, the quality of flow on the system, quality, like how comfortable you are as a user. Okay, from user point of view, how comfortable and convenient you are within this flow. Okay, so that is speed. So if system at high speed means high level of service, and vice versa. I think this is understood. Q is capacity of the system. V is the volume. Volume. How much volume is currently being carried by the system? Volume can be number of persons, number of vehicles, whatever. And M, as I told you earlier, is management system. Management system. Okay. Then we have Q Now Q, which is the capacity of the system, is a function of two things: infrastructure and management system. Capacity of the system is a function of infrastructure, how many lanes you have, how many buses you have, how many things you have, and management system. Okay, how you are operating it, how you are managing it. Okay, so the capacity can change with the change of infrastructure and management system. Okay, management system may decide that I should distribute the capacity on the basis of my own preferences. Okay, for example, management may decide I should provide more capacity for buses as compared to highways. Okay, because buses are more environmental friendly, they provide equal access to poor and rich and so on and so forth. Okay, so management decisions may distribute the capacities in different ways. For example, in Bahrain, what is the distribution of capacity? Highways take maybe 95% of capacity. 95% of trips are by the highways, and maybe the remaining 5% are by the buses. If the government decides, okay, now we are not going to spend on highway systems, we are going to improve our bus system. So the capacity will change. Buses will start to increase their capacity and highways will remain as it is with lower capacity. Okay, so this is the thing. Then demand is a function of speed and what is A? I forgot what is A. Demand is a function, yeah, activity, sorry, activity. Demand is a function of speed and activity. So activity we have already discussed. Okay, what is the distribution of activity? So some activities have more demand, some activities have less demand, and so on and so forth. And speed. Okay, so if you are providing better level of service, demand will increase. Providing less level of service, demand will decrease. Okay, providing more comfort and convenience for the users, they will demand more. Less, demand it less. Okay, I think the online systems are very good examples of that. Buying and shopping online, providing very comfortable service, the demand is increasing. Okay, I have not come to any studies, but we know. Okay, we know that demand for online systems are increasing. Why? Because of more convenience, more speed, and so on. Okay. So the combination of above equations, all these equations in combined are used to define equilibrium points over long and short term. Okay, so equilibrium means you achieve a speed which is fulfilling your demand. Okay, for all activities. Okay, so D, you achieve the demand by all these things. Okay, so we know the relationship. So speed affects demand, and speed is affected by Q, V, and M, and Q is affected by this and this, and so on and so forth. Okay, so you arrange these parameters in such a way that it fulfills the demand. It fulfills the demand. Okay, and demand can change short term and long term. So some decisions may change the demand over short term, maybe next few years, and some decisions may change the demand over the next 20 years. So you have to keep the arrangement of variables in mind for short term as well as long term. So there is a cause and effect relationship. There is a cause and effect relationship. So we have increase in income. I think we have already talked about it in the first slide. We are becoming money rich. So incomes are generally increasing with different rates, but they are increasing. Increase in income means increasing car ownership. Car ownership, more congestion, more delay, less mileage for the bus, reduced demand for the buses. Reduced demand for the buses means you will reduce the capacity of the buses, have less buses, less seats, and so on. Okay. So if you have less buses operating, it will increase the operating cost of the buses. You are managing the system with less number of buses, with less number of persons, it will increase the operating cost. Like earlier you were doing it for 100 passengers, now you are doing the same thing for 80 passengers. So your per passenger cost is increasing. So to cover the per passenger cost, you will increase the fare, right? To cover up the reduction in your revenue, you will increase the fare. When you increase the fare, what will happen? People will shift more towards a car because the buses are now becoming more expensive. Okay, so this is all generated by what? Increase in income, right? So what we should do, we should advise the government not to increase the salaries for anyone, right? Everybody agrees? We should advise the governments not to increase salaries for any person. Okay, so that this thing does not happen. Okay, I think you should agree. Everybody should agree on that. No, basically, what we do, like as a planner or from the government point of view, what they do is they intervene. You can see they intervene. So you see these arrows or these points here, they are the intervention of the government. Intervention of the government. Okay. So when you have more congestion on the roads, what you do, you apply bus priority. So metro is a bus priority system. Metro is a bus priority system. Or you may have heard about LRT or BRT. These are bus priority systems. So even here, if you have congestion on the road, buses are going from a separate lane or from a separate right of way at full speed. So this is what intervention from the government. Okay, the remaining 3 lanes will have congestion, but the buses will have priority. Okay, another intervention, instead of increasing the fares, the government subsidizes the bus operators. They will tell them, okay, if you are not making profit, we will give you the extra money, but keep the fares at the same rate, keep the fares at the same level. Okay, and so incomes are increasing, people will be starting to think to buy their cars. They apply car restraining techniques or car restraining strategies. More taxes on car ownership, more taxes on car registration, car fuel, and so on. Okay, so if you keep this running like this, okay, it will always go back to increasing car ownership. But through these techniques, we try to manage or maintain the demand for public transport and restrict the demand of car ownership. So you increase your income maybe by 50 dinar, and maybe the car taxes are also increased by 10 or 20 dinars. Okay, so it will not remain so attractive. Okay, but in certain countries, now I think this is not true, the book, it is written in the book, but in certain countries you may end up having very unrealistically high bus frequencies because the buses are priority. So you may see buses coming after every minute. Now 1 minute is not enough to board and come out of the bus. Okay, so you have to keep the things practical, realistic. Okay, there are 2 types of decision making styles. We call it substantive rationality and muddling through. Substantive rationality means, okay, have your goals in mind, objectives in your mind. If I do this, this much will be the cost. If I do this, this much will be the benefit. So everything is calculated and it is quantified. Okay, everything which is going to happen in the future, it's already thought about and it is already quantified. Okay, so you have some numbers. Quantified means you have some numbers. You have already calculated the numbers. Okay, but obviously with transportation or with any real world system, substantive rationality will not work every time. Okay, so if I increase the fuel prices, I cannot say exactly how the people will react to it. Will they reduce their trips? Will they reduce using the other modes? I cannot say for sure. Okay, so in many cases you apply the other technique, which is muddling through. Muddling through means what? You have the goal in your mind. Okay, I want to reduce pollution. I want to reduce pollution. This is my goal. To reduce pollution, what should I do immediately? Let us do what I can now, and we will see what will happen after that. Okay, so it's not, the goal is long term, but the planning is short term. Okay, the planning is short term and it is revised as a result of your action. Okay, so I did this. Okay, for example, I ordered that this type of cars will not be imported in our country because they are not environmental friendly. Okay, so after I make this action, I will observe it for a couple of years. I will see what happened. Okay, and then I will decide my next action. Okay, on the basis of that. Okay, this is what we call as muddling through. Okay, so in muddling through, you have immediate actions which are taken for short terms, but to facilitate the higher end or the long-term goal which is in your mind. And after you take one action, you will decide about the next action when the results of the previous action come into your vision. Okay, but in substantive rationality, you calculate everything, all the alternatives for the future right from the beginning. And obviously, both approaches have their own benefits and disbenefits. Okay. How do you select the approach? Should I go for muddling through or substantive rationality? It depends upon these things, precision and accuracy. Now, can someone tell me what is the difference between precision and accuracy? Go ahead. What is the difference between precision and accuracy? Very common terms. You must have heard it in other courses or even not. These are very general terms. Who can give me the difference between precision and accuracy? No one? I just count to 5. 1, 2, 3, 4, 5. Okay. So this will come in the exam then. Okay. Decision making context. Okay, meaning in which context you are making a decision, from which perspective. For example, are you thinking about the traveler? Are you thinking about consultant firm? Are you thinking about the government? Okay, what is your perspective? What is the scope of your decision? Okay, which, like, are you just talking about a country? Are you talking about one city? Are you talking about one specific type of user? Okay, how much is the coverage, like in terms of space? Okay, level of detail you need. Okay, how much area you want to cover? What is the unit of your analysis? Okay, for example, you are doing it for long term, short term. Okay, you are doing the analysis on hourly basis or daily basis or yearly basis. What behavioral response you are trying to get from the system? Okay, are you talking about changing people's mode choice? Are you trying to change people's job choices, or you're trying to change their car ownership decisions, or what? Okay, handling of time, how much time you have, okay, to implement and make your strategy and so on. Availability of suitable data, okay, how much data is available which is accurate and precise and so on. State of the art in modeling. So when we say state of the art means what? What do you have right now? Like, what is the most modern or latest thing which you have right now? That is state of the art. Okay, so what is the most latest technology and technique you have in terms of modeling? Okay, so like you can say I want to model this and this, but in order to model these things you need you don't have the softwares, you don't have the people and so on. Okay, so state of the art in modeling, what techniques are available, okay, and that you can utilize. Okay, so I want to model, for example, autonomous vehicles. So what is the latest technique or what is the latest software which is available in the market to model them? Okay, then how many resources are available? The money which is available, the data, computational support like systems and softwares and infrastructure you need, technical skills you need. Okay, and then how much time you have. Okay, so all these things will affect your decision making approach. Okay, all these things will affect your decision making approach. Okay, so either for example, if you are doing the decision making, I'm just giving one example, you can think about others as well. If you are doing decision making for the entire country, okay, but you do not have enough data, or you do not have enough time to calculate everything for, let's say, next 20 years. Okay, then maybe you will go for this approach. Okay, So this is how you can decide about your modeling approach or decision making approach. Okay, issues with modeling. When you are doing the modeling, there are issues you need to take into account. Role of theory and data. Okay, what should be the role of theory and what should be the role of data in your models? Okay, models generally provide rationale to your theories. I have a theory which I can prove through a model, through an equation. Okay, in order to prove the theory, I need the equation. In order to run the equation, I need the data. Okay, so this is the thing. Model specification. Model specification includes what should be the structure of the model. Okay, like should the model be a linear equation or a complicated log equation or exponential equation? What should be the form of the equation, form of the model, functional form? Should I use cosine laws, sine laws? Okay, there are many different forms: exponential, logarithmic. Variable specification. Okay, variables can be discrete, continuous, fixed, and so on and so forth. So all these things come under model specific. What type of equation and what type of variables you are going to use in the model. Then model calibration, validation, and use. Calibration means you are developing the equation. Validation means you are looking at the accuracy of the model in the light of data you have. So you have used some data to develop the model calibration. Then you have used another data set to know the accuracy of the model. Okay, so I have a model between price and income. I have the model, sorry, let's say I have the model between bus fare and fuel prices, bus fare and fuel prices. Okay, so in order to develop this equation between bus fare and fuel prices, I will take some data for, let's say, 2 years. Okay, so 2 years from, let's say, 2018 to 2020, I have taken the data for bus fare and fuel prices. I have developed an equation. Then in order to validate the equation, I will apply this equation to the data of 2021. So can the equation produce accurate bus fares using the gas fuel prices of 2021? This is known as validation. Okay, and then we have the use meaning future forecast. If the equation is accurate, you will go for future forecasts. Okay, so now I can use the equation. So now I will forecast the bus fares in, let's say, 2025. So this is model calibration for future, validation for current, and use for future. So sorry, model calibration for past. Okay, so you are doing the modeling here, and this is the actual world. This is the actual world. Okay, so you are taking data from the actual world, and then you are forecasting something, and the actual world may be going like this. Okay, so you see there's a box which is restricting your model. Okay, what is the difference between the real world and your modeling world? This box. So what is this box? This is the set of assumptions you are making. Okay, so whenever you develop some equation, you assume certain things. Okay, that the people will behave in this manner, fuel price will increase by this rate, bus fares will keep constant, or the bus quality will remain the same, or so on and so forth. So all these are assumptions. So the output of your model is restricted because of these assumptions. If any of these assumptions is not valid, your model will not work. It will be far from the actual scenario. Give me a second. Okay, so you have to deal with the issues with modeling. Okay, modeling including calibration, validation, and then the forecasting, which is done for the future, and then your judgment. Your judgment is basically telling you which assumptions to make, which assumptions are correct and wrong, and how they will change, and so on and so forth. Aggregate and disaggregate modeling. Okay, aggregate means what? Who can tell me what aggregate means? The word aggregate.
Total.
Total, yes. Aggregate means total and disaggregate means individual. Aggregate is total, disaggregate individual. Okay, simple. I think this should make it simple. So aggregate is when you are modeling group of travelers. Okay, the entire population of travelers. For example, calculating average car ownership ratio for an area. Okay, so in this area, for example, if I tell you in this area 80% of people have cars, this is what aggregate number, and I might have calculated using some model or equation. Okay, disaggregate related to individual traveler, individual behavior. For example, mode choice. So when I say mode choice, I will say mode choice of Muhammad is a bus. So this is my forecast, or this is my output for only one individual, which is Muhammad. Okay, so this is disaggregate. So when you develop equations which can predict behavior of individuals, this is disaggregate modeling. When you develop equations that can predict the numbers for an entire population, for entire area, this is aggregate modeling. Okay, so aggregate modeling was very popular in the last century up to 19. Even now we use it. Even now, traffic forecasts and weather forecasts, we all are all done using aggregate modeling. Okay, so it's not obsolete, but it's not that popular now. So the problem with aggregate modeling is inflexibility, inaccuracy, and cost. Okay, you require very large amount of data, so there is more cost involved. They are inflexible. Like I showed you, car ownership, it will only give you the car ownership of the whole area. It cannot tell you about the individuals. Okay, in certain manner, it can be inaccurate as well, because you are saying 80% of the people in this area have cars. 80%. So 80% means what? So in my house, if there are 5 people, 4 of them will have car? No. Okay, so they can be inaccurate and misinterpreted as well. Disaggregate, it became popular from 1980s onwards, and it has more advantages over the traditional methods, but it requires more statistical and economic skills. To develop disaggregate modeling equations, you require more skills, more computation power, and this is the reason why they have become more popular nowadays. They have become more popular nowadays because now technology is no problem for us. Alhamdulillah, we have the technological solutions have become more superior now. Okay, so since we already have the skills and we are going way forward in technology, so disaggregate becomes more popular for us. Okay, so now you will see, I will just give you a word, okay, and then you can maybe search for it. We call it agent-based modeling. Agent-based modeling. Okay, so agent-based modeling. You have seen Matrix movie? Anyone? Matrix.
Yeah, doctor. 3 parts.
3 parts, all 3 of them. Okay.
I'm waiting for the 4th one.
For the okay. How many are there? How many parts are there?
3 done and 1 is upcoming next year.
Upcoming. Okay. Let me know.
Yeah, I will.
Okay, so you if you've seen Matrix or any other similar movie, they are basically examples of agent-based model. Okay, so in that movie, what they were calling as an agent was basically a real world representation, right? A real world representation of someone who can be in the real world. Okay, an agent was a real world representation. Okay, so this is what we call as agent-based modeling. You develop a computer program, and that computer program, every individual is programmed differently as an agent. Okay, so anyone who has not seen the movie, okay, go and have just have a trailer or something. Okay, or just read the plot. Okay, if you haven't seen the movie, just read the plot. Okay, and this is the most detailed level of disaggregate modeling. That movie is the most detailed level of disaggregate modeling, or what I'm calling here as agent-based model. This is the, as per my information, the most detailed level of disaggregate model, where every individual is designed and introduced in the model separately. So you have a whole system, and where if I have 1,000 people in the system, everybody is a different individual, just like the real world. Okay, so this is agent-based modeling. Okay, if you don't like my example, please forgive me. I cannot help it. Okay, I'm just trying to give the best example I can. Okay. So it requires high level of statistical and economic skills for disaggregate modeling. Okay, so agent-based modeling or any other type of disaggregate modeling is not easy. Okay, this is the main thing with that. Then we have cross-sectional and time series data. Cross-sectional means I take your data. For example, let me give you an example. I take your grades, your, let's say, CGPA, your GPA, your cumulative average GPA now. Okay, for all students in the master's program, let's say. Okay. And I do it just one time. I do it just one time. This is cross-sectional data. Data which is collected at only one time. This is cross-sectional data. Okay. Now, if I make a policy on the basis of this data, for example, I see in the data people from transportation have higher grades, people from structures have lower grades, or vice versa, or whatever. So I make a assumption that maybe I should do something for people who are in transportation. I should provide them more courses, more examples, and so on. And I make a decision on the basis of that. But I did not consider your background. When I collected your time series data, I did not consider your background. Maybe these people who were having less grade from transportation, they were already students who were having low grade in the bachelor's as well, in their engineering courses as well. I did not see that. So then it comes to the question of time series data, or what we call as longitudinal data. So the data is collected over a series of time for the same individuals. So for example, I collect your data now, and I will take your data from the last, or from your bachelor's, and maybe I will collect your data from your high school as well. So now if I make a decision, I can see your own change in behavior over the time. So when I make a decision about you, it will be more informed from the behavior point of view. So this guy, he's always having low grades. Okay, so it's not because of the program, or it's not because of the courses and master's program. It is his own doing. This is his own background. This individual was scoring very high in bachelor's, up to bachelor's, but now in master's his score is low. So maybe he needs more support in the master's program, and so on and so forth. So a time series data gives you more insights into the behavior and what can happen in future, or what should be done in future, because now you can imagine why a particular response may change for an individual. A particular parameter may change for an individual. Okay, because you have seen the same data over a series of time. Okay, so this is what we call as longitudinal time series data. So cross-sectional data, very easy to collect and can be done in a very short time. Time series data requires more time. Okay, you can do it in panels. Time series data can be collected in panels as well as in before and after studies. Panel meaning you are a panel. You are a panel. So I hire you, or I engage you, and I tell you, okay, for this 1 year, whenever you do this thing, let me know. Okay, or I will record your data. So for this 1 year, whenever you are giving the exam, I will record your grade. This is a panel. Okay, voluntary person who will come to record or give the data. Okay, or you can do before and after studies. Okay, so I made a change in my teaching methodology. For example, I will take data before the change, I will take data after the change. Okay, or for example, I change the speed on the road. So I will collect data before change in speed, I will collect data after change in speed. Okay, so this is a simplified way of time series. Either request some people to volunteer for your program, so your data will be limited to those people, or you can do just 2 times before and after a change. So again, this data will also be restricted to the change. Okay, so cross-section studies, more convenient, less time. Time series studies, require more involvement, more people, and so on. Revealed and stated preference data. Revealed means what you are doing, I will observe it. What we are doing, I will observe it. This is revealed preference. Stated is what they usually do in market research. Okay, so I don't know, in Pakistan I have attended some of these. So they will come to you and they will say, sir, are you willing to buy this product if the price is this much? Okay, I know a few organizations in Pakistan that do that. Okay, I have not come across any survey like this here, but in market research this is very common. This is very common. They will come to you, sir, are you going to buy this product if the price is this much? If I say yes, this is stated preference. Who knows? Maybe I will buy, maybe I will not buy. So this is stated preference. Revealed is, okay, price was 1 dinar and these many people bought the product. This is revealed, observed. Okay, so again the problem with revealed preference is that if you are looking for a new option, a new product, a new service, then revealed preference will not give you any insight. You can just assume that the people may, okay, since the people are now going by car, so if I increase the fuel prices, they may reduce the car and so on. This is your assumption. You did not actually ask them. But in stated preference, I may go and ask them, what will happen if I increase the fuel price? So if they say, yeah, I will reduce my trips or something like that, this is stated preference. So in revealed preference, we only take the data of something which is actually happening. A stated preference, we take the data of what can happen. Okay. And both approaches can be used complementarily together. For example, in my PhD, I did it. I took data for the current options which they had, and then I asked them, what will happen if a new ferry service or a new train service is started? What will you do then? So I had the data for their current choice, and then I asked them, what will you do in the future? So I had both types of data, and I can analyze both types of data together. This is a classic 4-stage transport model. Okay, we will have a break maybe after how many? Where am I? I'm here. Okay, so 5:45 again, we will have the break for 15 minutes, inshallah. Okay, this is what we call as classic 4-stage transportation model. First of all, divide the area into zones, collect the data for the present, which we call as base year, take the future planning data from other agencies, So this will make the base year data. Okay, then start with trip generation, meaning how many trips will be generated. Trip distribution, meaning to which areas these trips will go. Modal split, meaning which modes of transportation will be used for different trips. Assignment, meaning to which routes, to which highways these trips will go. Okay, and at each stage you may and then you will have the output in number of trips on each highway. Okay, and then this is a iterative process. This is an iterative process. Okay, so for example, you on the basis of model split, you may change the trip generation as well. Okay, and so on and so forth. So transportation model, so I have given you one sequence here: generation, distribution, model split, assignment. Don't worry, we will discuss this model in detail, inshallah, coming from the next class. Okay, so don't worry about understanding it fully. I know you cannot understand it fully right now. So trip generation, so some of the sequence can be changed. For example, trip generation and model split can be together. So you calculate how many trips will be generated from each mode together, or trip distribution and model split can be together. For example, how many trips will be going to each area and from which mode, so they can be together. So the sequence can be changed. So how do you do the modeling process? First of all, calibrate the model for the base year, present scenario. How many trips now? What is the model split now? How many trips on each highway now? Everything for now. Then generate future scenarios. What you are going to change in future. Okay, so I'm going to build another highway. I'm going to start another bus service. I'm going to start the more taxes on fuel. So generate future scenarios, and you can have alternative scenarios. Okay. For each scenario, run the model to see the results, the number of trips in future for each scenario. Okay. So different alternatives you have. On each alternative, run the model, see the future demand. On the basis of that, calculate future cost and benefits for each alternative, and then you adopt the most attractive alternative, okay, which satisfies the demand of the area. If the demand is not satisfied, for example, you go for alternative 1. Alternative 1 doesn't satisfy the demand, it is cancelled. Okay, you will ban it, take it out. You have other 3 alternatives. Out of those 3 alternatives, see which one is the most attractive one, meaning most attractive meaning less costs, more benefits. Okay, what is the issue here? The iterative nature. Like I told you, trips on a route may change the travel time. Number of vehicles on the route, number of vehicles on the highway may change its travel time, and travel time may change modal split, which mode you are going to use for your trip. Okay, so this is the iterative nature. So you change one thing here, and then you have to maybe see the effect of this change on distribution and modal split and assignment again. So this is the main issue with the modeling process, that it is iterative and cyclic. So then we introduce continuous transport modeling framework. Okay, so in continuous transport modeling framework, formulate the problem. What is the problem? Okay, one important aspect here, this cycle, keep it in mind for developing your research proposal. When you are going to develop your research proposal for the master's thesis, follow these steps, it will be very beneficial. Formulate the problem. What data you need? Construct the model. Okay, in the case of your thesis, what are your objectives, what are your goals, and so on. Okay, then take the data for future from other agencies, other organizations, generate solutions, alternative solutions, test the model using the future data and the solutions which you have provided, and then maybe you can recalibrate the model. Okay, maybe go back and maybe change the problem. Okay, because the model is giving you that this solution is effective, this solution is not effective, this will have this much cost, this will have this much benefit. So you can again go back and maybe change the problem or maybe change the model. Okay, and then if everything goes well, don't need to change the model or the problem. Come to the next stage, find out the best solution, and then implement the solution. Okay, so follow these steps when you are developing the proposal of your thesis. Okay, and in this cycle, we are assuming that we are following the rational approach for decision making. So everything is calculated. Okay, since we know rational approach is not possible for the things in real world, so we apply a function monitoring system as well in the same cycle. We have a function monitoring system, so that will be your supervisor. That will be your supervisor who will supervise your thesis. Anyways, so this function monitoring does what? Anywhere where the variables are going out of your expectation. So you were expecting the variables will have this value, but now they are showing a different value. So this function will say, okay, now go back to data collection again. Maybe there was a problem. Okay, providing data for further validation enhancement of model. So this monitoring function will tell you how can you improve your model. Okay, provides learning opportunities. So when you are improving the model, you are learning yourself. Planning process becomes continuous. Okay, because of the cyclic nature, the planning process becomes continuous. So you keep on improving the model and getting the results. Okay, we have theoretical models and pragmatic models, or experience models, experience-based models. We call them empirical models. You might have heard the word empirical model, analytical model. So these are all part of experience. Models or equations generated from experience. Okay, theoretical models, they are stable, they give consistent results. Okay, you can have confidence in your forecast that you will get the same forecast every time you use it. It provides you more understanding of the system and the algorithm, and it provides you more understanding of the variables. These are the advantages of the theoretical models. but theoretical models do not work everywhere. Somewhere we have to use experience or pragmatic models as well. Why? Because of these reasons. Theoretical models are very complicated, more complicated than analytical models. They require more data. Real matrices are easy to work with. Real matrices made up of real numbers, data collected from the field. Instead of the models, they are better for understanding. Theoretical models cannot be calibrated to minor details because we have to make them simpler to adjust to the theory. Same model cannot be used in different problems. Same model cannot be used in different problems if it is a theoretical model. So because of these disadvantages, we go for analytical model. Okay. So we will have a 15 minutes break. After the break, we will start with transportation economics and be here immediately after the break because we will be doing some numericals. Okay. So have your calculators at hand, and this whole topic is about numericals. Okay. So I will be focusing more on problem solving. So have your calculators at hand and join immediately. Okay. So after 15 minutes, inshallah. Assalamu alaikum.